Very good morning, students. This is Dr. Eustace Russell, working as an assistant professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are discussing the subject called Robot Dynamics and Control. For the past two units, we have covered some topics in Unit 1 and Unit 2. Now, we are going to again meet in this subject called Robot Dynamics and Control with the subject code of RA 3601. Which is coming under the regulation of 2021. Now we will see one by one the syllabus of Unit 3, the introduction of Unit 3 we will see. So the Unit 3 is nothing but a robot control system. In this, it covers manipulator control problem, linear second order model of manipulator, function of controller and power amplifier, joint actuators, step motor, servo motor, control schemes, PID control scheme, position and force control schemes, robotic sensors and its classification, internal sensors that covers position, velocity, acceleration, and force information, and external sensors, contact sensors, limit switches, piezoelectric, pressure pads, non-contact sensor, range sensor, vision sensor, robotic vision system, description of components of vision systems. These are the important content which is covered in Unit 3. In the first part, we will see a few topics as part 1. Let us see one by one. Now, the first thing is joints, actuators. In that, we are going to see functional units of a robot. First is the mechanical units, that is robot arms, that is rigid links connected through rotational or prismatic joints, that is having 1 degrees of freedom, mechanical subdivisions, supporting structure, that is having mobility and rest, that is dexterity, end effector task execution, example manipulation. In this, the dexterity is nothing but a complex motion. The robot will accompany in complex motion, that will be called as dexterity. Sensor units is nothing but proprioceptive internal robot state, that is position and velocity of the joints. Exteroceptive, that is external world, force and proximity, that is vision. Activation units, that is covering of motors, motor control algorithms. In the motors, you will have electrical, hydraulic and pneumatic. Supervision units, you have task planning and control, artificial intelligence and reasoning. Mechanism is a mechanical system that has the main purpose of transferring motion or forces from one or more sources to one or more outputs. So this kind of mechanism is nothing but, that is transferring motion is nothing but called mechanism for one source. That is from one source to another source, that will be converted from one to another source as an output. In a robo, where we will get output, the end effector, finally you will get that mechanism is converted to get the final motion in the end effector. The linkage is a mechanical system consists of rigid bodies called links that are connected by either pin joint. This type of linkage, links, joints is a basic concept we have studied in kinematics and dynamics of machinery. Mostly mechanical students will study, and mechatronics also students might have discussed this topic, as well as degrees of freedom also you might have studied in your earlier semesters. The degrees of freedom is nothing but the number of independent variables or coordinates required to completely specify the configuration of the mechanical systems or sliding joints. So DOF, in short form, you will tell us DOF, that is we call degrees of freedom. Now robot joint. Robot joint can be either rotary also known as revolute or prismatic, that is telescopic. We can see that here in the diagram we can see it is mentioned as revolute. We having the two links, link 1 and link 2, having a rotation of revolute like that. The robot joint is a mechanism that permits relative motion between parts of a robot arm. The basic movements required for the desired motion of most industrial robots are rotational movement. This enables the robot to place his arm in any direction on a horizontal plane. To place his arm in any direction, that will be the important case. That is called rotational movement. Radial means this enables the robot to move his end effector radically to reach the distant points, that is called radial movement. The vertical height is nothing but this enables the robot to take his end effector to different heights. So this is that to reach the distant points. In this we have the end effector to different height, both are different, to reach distant points as well as to take his end effector to different heights. We can see in the diagram in the right hand side of your slide, we can see the various type of joint that is mentioned over here: linear joint, rotational joint, twisting joint, and revolving joint. This is the sketches for your reference. Then the rest is the linear joint. Linear joint is nothing but can be indicated by the letter L joint. That is called L, the linear. This type of joint can perform both translational and sliding movements. These motions will be attained by several ways, such as telescoping mechanism and piston. The two links should be in parallel axis for achieving the linear movement. Rotational joint can also be represented as arc joint. This type will allow the joint to move in a rotary motion along the axis, which is vertical to the arm axis. Twisting joint will be referred as V joint. This joint makes twisting motion among the output and the input link. During this process, the output link axis will be vertical to the rotational axis. The output link rotates in relation to the input link. That is called twisting joint. Then revolving joint is nothing but revolving joint is generally known as V joint. Here the output link axis is perpendicular to the rotational axis and the output link is parallel to the rotational axis. As like twisting joint, the output link spins about the input link. That is called revolving joint. This one important term is output link will be spins about the input link. That will be the considered as a main point. Based on the input, automatically it will rotate, the output you will get. That will be fixed in the frame or anything. Twisting joint also output link rotates in relation to the input link, the same thing. Then actuators control. We can see robots are classified by control method into servo and non-servo robots. Non-servo robots are essentially open loop devices whose movements are limited to predetermined mechanical stops. That is, non-servo means what? Essentially a open loop devices. Servo means it will be a closed loop computer control to determine its motion. Then you will see actuators. Actuators are the devices which provide the actual motive force for the robot joints. Normally, actuators are the muscles of robots. If you imagine that the links and the joints are the skeleton of a robot, the actuators act as muscles which moves or rotate the links to change the configuration of robots. The actuators must have enough power to accelerate and decelerate the links and to carry the loads. It be light, economical, accurate, responsive, reliable, and easy to maintain. This is one important. Actuators in robotic system basically consists of power supply, power amplifier, servo motor, and transmission system. So in this, actuators will act as a muscle, just like a human body, which moves or rotate the links to change the configuration of the robot. That is one type of purpose. It will access to change or to move and de-accelerate the links and to carry the loads. Then actuator system, we have the power supplies and the power amplifier, motor or servo motor, and the transmission is there. Various sources we can see. The left hand side it is mentioned over here. That is primary source of power, electrical press, fluid and compress and air. Input control power, usually electric, that is PC. The input power to motor, electric, hydraulic and pneumatic, that is PA. Power output from motor, that is PM. PU is nothing but mechanical power required. And these are the characteristics of an actuator's: load, speed, accuracy, resolution, repeatability, reliability, power consumption, energy supply, and its weight. These are the important characteristics of an actuators while designing components. Then types of actuators. So based on the source of input, power actuators are classified into three groups, that is pneumatic actuators, hydraulic actuators, electrical actuators. Pneumatic is nothing but provided by the compressor and transform it into mechanical energy. That is, pneumatic is nothing but by use of the air. By the name itself we can see. Then hydraulic actuators, these transform the energy stored in the reservoir into mechanical energy by means of suitable pumps. Then electrical actuators are simply electromechanical devices which allow movement in the use of an electrically controlled system of gears that provide the location by wheels or legs and for the manipulation by actuating robot arms. Pneumatic and hydraulic actuators are used in industry for large manipulation tasks but seldom for mobile robots. Both these actuators are powered by moving fluids, that is called air or uh, oil type, that is hydraulic. The first case, the fluid is compressed air. Second will be, as I already told, is a pressurized oil. This having the ranges, it is mentioned over here. 100 lb per inch square. This is 1000 to 3000 lb per inch square. So upcoming session we will see about the uh, actuators in elaborate from the types. We will see in the upcoming lecture also. So these are the reference which I used for preparing this slide. Kindly go through this reference. So thank you, students. Thank you all for your kind attention. Please go through the references. Please subscribe the video and share this video to your friends. So we will see in the upcoming lecture videos. Thank you one and all.